Video, we are going to discuss about the how we can measure the stopping potential and then Planck's constant using photoelectric effect. Coming to the stopping potential point of view, how much reverse potential is required to stop the electrons coming from the earth, from the cathode to anode. So at that moment, the current value is 0. This is the mechanism related to the stopping potential which is involved in the photoelectric effect. By using this concept, we are going to measure the Planck's constant which was proposed by the Plancks in explaining the photon concept E equivalents to h nu. Here we are measuring the Planck's constant with the help of photoelectric effect by measuring the stopping potential. For this, the photometal is required. As we know, in case of photoelectric effect, once the light strikes the photometal, electrons are emitted. This is the photometal, and here positive, negative, one is act like a cathode and another is act like a anode. This is a light source, so it's like a white light source. It gives the all kinds of frequencies. So if you want to change is a light, it gives the all kinds of frequencies. If you want to change or if you want to apply specific frequencies, we are using filters. We're having like blue, green, orange, and red. So these are 4 different filters so that it restricts the light and it allows only a particular frequency to photometal. In addition to this, we are also having Planck constant apparatus, which is consisting the microammeter and the voltmeter to measure the stopping potential by giving the current value 0. These are the complete components required to measure the Planck constant with the help of photoelectric effect. Coming to the circuit diagram point of view, in which way we need to connect the components to measure the stopping potential. So before going to the circuit connections, we should understand the meaning of photoelectric effect. Coming to the photoelectric effect, a circuit diagram point of view. So this is the photometal and it is a cathode, and the collector or detector is take it as the anode. Once the light of suitable frequency strikes the photometal, electrons are coming out. So according to the concept, this light need to maintain some suitable frequency that we are called it as threshold frequency. So the minimum amount of energy required to emit an electron is take it as the work function. So if the light supply energy is more than, like a photon energy, more than the threshold or the work function, then the electrons are coming out, and these are electrons are collected by the anode. This is a complete circuit diagram related to the photoelectric effect. This is the ammeter to measure the current flow within the circuit. That is, it is decided by the how many electrons are reaching to the anode. This is the potential. If the potential is more, then obviously attracting capability is more because it is like a positive. So the potential difference in between the negative and positive is more. These electrons reach to the anode in a fast manner. So once the potential is more, electrons are reaching to the anode is more, which in turn increase the current value. Now we want to measure the stopping potential in this particular experiment. Stopping potential is nothing but, just assume the stopping potential is nothing but electron is not reaching the anode. We need to apply the opposite potential, reverse potential, which is oppose the electron flow from the cathode to the anode. once the electron is released because of the light, it has some kinetic energy. Because of this kinetic energy, electron is coming towards the anode. Now our aim is to stop the electron to reach the anode. That it means that we need to apply the reverse energy, which is possible by applying the potential in a reverse manner. So then obviously these terminals need to be reversed. So in case of terminal point of view, so we are changing the potential terminal like this. That is, here we are taking it as this is the negative and this is the positive. So we just change the potential terminals, then obviously anode is applied by the opposite potential, then this opposite potential, it is negative. So negative and the electron is repel each other. So if you apply the suitable negative potential here, then obviously it stops the electron flow towards the anode, because of at that particular moment the current value this ammeter is 0. The amount of reverse potential is need to be maintained to make the current is 0 is take it as the stopping potential. For this in the measurement of the stopping potential we are using this concept. So obviously cathode need to connect to the positive of the potential and anode is need to connect to the negative of the potential. So connection point of view, just see here the photometal, the cathode and anode. First I connect to the voltmeter. This positive terminal, like a already discussed, the reverse potential is applied. So this positive is connected to the voltmeter, negative. This is the first step. The photometal positive is connected to the voltmeter, negative. So photometal positive is connected to the voltmeter, negative. So this anode is connected to the voltmeter, negative. So this ammeter can be connected at any moment, right? So I just place the ammeter here. So then voltmeter positive is connected to the ammeter positive. Voltmeter positive is connected to the ammeter positive. See here, the voltmeter positive wire is connected to the ammeter positive, and remaining ammeter negative is connected to the photometal negative. See here, ammeter negative is connected to the negative of the photometer. Now the connections are over to measure the stopping potential. Now by changing the potential value, our aim is to reach the current value 0. That particular potential is taken as the stopping potential. Here one more change we are taking. So light of not constant frequencies, we are giving the different frequencies by using the filters. So obviously these filters are used to filter all the light, and it only allow the single frequency light. So here for example with GR point of view, so violet to the red, wavelength is more, frequency is less. So red light having the frequency less and blue light having the frequency more. By using this particular concept, we are giving the different frequency light sources to measure the stopping potentials. So this Planck constant apparatus gives both the microammeter values and voltmeter values. Here the direct white light strikes the photometer. Now we are changing the frequency of the lights. So now initially we are giving the blue light. See, now I filter only the blue light. Now the blue light is entered into the photometer. Here just see here, microammeter value is minus 4.27 and voltmeter value is 0.03. But these readings are not suitable. We want to maintain the microammeter value to the 0. I just adjusting the knob here. See here, ammeter value is getting down and stopping potential is increases. As reverse potential is applied more and the current is reached to the low value, and then finally it is showing like a zero value. So whatever the corresponding value relate to the voltmeter, you should note down that is representing the stopping potential for the blue color. Note down these values. Now we are changing the blue into the other color. Now we are using the green in the place of blue. Now see here, the values are changing. So again we are adjusting the read meter to maintain the zero value. So for green it is showing like a 0.738. Similarly we are measuring the values of stopping potential for red and orange also. Now we place the orange and zero point 564, it is getting 0. The last one, red is replaced. Orange is replaced with red. For red light, the value is 0.336. These are the measured values for different colors. Blue 0.983, green 0.738, orange 0.564, red 0.366. So these values are not fixed values. These values may change with the distance and intensity of the light also. And coming to the, so blue having more stopping potential, as we know that blue having the more highest frequency compared to these colors. If it having highest frequency, that means that we are sending with the most energy photons towards the photometal, then obviously released electron having more energy. So if you want to stop the high energy electron, then obviously we need to apply the reverse potential is more. Because of this, blue is having more stopping potential compared to the red. This is a trick to observe or to understand whether we are getting the correct values or not. So these values are used to measure the Plancks constant. In what way we can measure the Plancks constant with the help of these values, we'll discuss here.